just in case I need it. Hopefully that won't slow us down too much. All right, so when we talk about graphical user interfaces, all the programs we've run so far, all the programs you've submitted as homeworks have been pretty simple insofar as how they interact with the user, right? You generally throw up some questions onto the screen, the user types in some answers, and then you use those answers to process. Maybe you open a file, you take in your input and you go on. And then you give some feedback along the way. Maybe, in the simulation loop, you'll say how many berries there are, or how many bears or tourists, or maybe you'll even show a map, right? And that's kind of what we're talking about in your homework 8. Up until 20 years ago, that was pretty much a way, maybe 30 years ago now, that was the way most programs operated. And then we got this invention of something called graphical user interfaces. And graphical user interfaces allow you to interact with it more along the lines you would interact with, for example, your phone, which is a very graphical user interface, right? So we have our phone here, and you can, unlock it, I think, right? And then if you want to do something, you can come in and you can, click on a button, and it brings up something, and I don't know what button I clicked, so I don't know what it brought up. It brought up my stock stuff, so Dow Jones and things. And that's a graphical user interface. And the cool thing about the graphical user interface is it allows you to use that visual component instead of a textual-based component where you have to read and respond to questions. You can use the visual components to make things more intuitive, to make things more colorful and more interesting. You'll be familiar with most of these, right? You have buttons that you can press, right? The buttons on the screen, not the buttons on your mouse, right? You'll click the mouse button to click your screen sometimes, unless you have a touch screen. But buttons on the screen, text input fields, radio buttons where you can select one, or check boxes where you can select many. And these allow us, again, to interact with the system in a more intuitive way and in a more powerful way, and give back more powerful feedback as to what's actually going on. It would be hard to do a VR environment, for example, doing a text-based simulator, right? Although we did have games, X-Hack for going down into dungeons, etc., that did draw a map on every level. All right. Where are we? Oh, yeah. So this is not a course about designing GUIs, by the way. And you will not be a good GUI designer after one class in your Python CS1 class. So the graphical user interface, how to design a good interface that provides maximum information to people with a minimum amount of clutter, that is visually appealing, that effectively tells people what to do, is gives people information, is a very difficult concept. You can do very bad interfaces very quickly. So if you're interested in that, if you're interested in GSAS, if you're interested in designing applications, and you're thinking you're going to become the next, next Jack Dorsey with Twitter, make sure you spend some time and take some classes on effective communication, visual communication, or HCI, human-computer interactions, because they are actually fields of study, and there are best practices, and you can actually learn a lot. So just be careful with that. Don't think that knowing the mechanics of doing things is the same as being able to do them well. And also, most of the GUI packages, including TKinter, start out with some bad UI battles. There are whole websites devoted to flashing lights and blinking text that tell you exactly what not to do. So please pay attention. The defaults in most packages are pretty good. So if you have to, if you're designing something, the best thing to do is to kind of stick with the stuff that's pre-canned, so that you turning off my picture in the hopes that it will lower the burden on the system and won't look quite so choppy. So Don't override defaults until you know what you're doing. The defaults generally are a sane setting. Whether they're the best setting or not, probably not, but they are at least sane. Okay, so right along with the graphical user interface is something called event-driven programming. So what does that mean? Well, again, we've been doing straight line programs, right? You may come down and put your program into a loop, right? You may, you're not executing just a single path through. You may have branching conditions that cause you to do different things at different times. But in general, one line of your code follows directly after another line of your code. What we're going to do with GUIs is that doesn't work so well because you don't know what button's going to be pushed next, and you don't know what the user is going to choose to do next. So with graphical user interfaces, they're designed to do something in response to an event. Push the button, select from a list of options, even moving your mouse into and out of a window, etc., are events that can be captured and that you can attach actions to. Okay? So what you need to know is you need to have this concept of your main window, the place where the operation of your program is actually being monitored. And that's going to sit there essentially in an infinite loop. And it's always going to be waiting for a specific event. And as the events happen, it's going to fire off code to handle those events. And the important thing to note is that firing off one event doesn't stop you from firing off another event. So a GUI is always in an infinite loop. When it gets an event like a button push, like you click on a button on the screen, it executes the function corresponding to the event and continues to listen. And you can actually have it responding to multiple events at the same time. Now, of course, a single processor with a single core can only execute one of those, but you can switch back and forth. It has the ability to, as you learn in operating systems, to run multiple programs or multiple threads at the same time. Infinite loops are bad. So you do need a way to get out of them, right? You need a way to kill your program. So there's often an explicit termination command that has to happen. All right, and what else here? And this is the very important note. Events happen in parallel. So your program will be listening for new events while it's executing old events, and it can even be executing multiple events at the same time. All right, so let's just start talking about this, or let's start looking at some examples. Let's pop this off. This is a very simple program. Let me see, what do I want? I want to go to Spider. And that's not a very simple program. That is the program that I was playing with before you guys came on. There we go. This is a very simple program. So let's talk about what this does. TKinter is a module just like any other module in Python, right? So we can, from TKinter, we can import stuff. This is traditionally the way it's done. Now, I have told you that I don't like import star. I don't like import star even here, but it's standard. It's a way it's often done. It's kind of the community standard, so I don't object to it too much. But we import TKinter. That gets us access to the TK module. This creates a new instance of a TK graphical user interface, and it assigns it to the variable root. Root main loop. This is our infinite loop. Can't see my cheat sheet. I want to make sure I hit everything. Yeah, so this is the infinite loop. So we create a window, and then we tell the window to spawn itself off and start listening for events and listen for events forever. And then we have this little print hello out here that should come down and print something there. I think what I'm going to do is add another line, print, I don't know, getting started. Okay, so let's run this and see what happens. So when we run this, right, we come down and good, that worked. That was what I was playing with before you guys came on, was making sure that this would show up. Right, so we have, let me move this window so I can see what's going on. All right, so, right, we've come down, dang it. There we go. Now I've got to get this back again. I hate the fact that when I double click, I'm double clicking on the wrong window. So instead of highlighting stuff that I want to highlight, I full screen and unfull screen my my machine. All right, so we come in, we import the TKinter library module. We create this TK object, right? This is just another class. You can look in the TKinter Python file and see what you're actually getting. And then we hit this print getting started. And what I want you to note is that when we hit this print getting started, we brought up this silly little window that I can no longer see because I got, where is that? There it is. You guys can see it, I can't. We brought up this little window. It is a little hard to see. Let's make it bigger. Yeah, so import star means to import everything. Okay, I can't get you to see that. There's actually if you run this, there's actually a line up at the top that I can't seem to get you guys to see. Let me try this. There, is this better? Maybe. There we go. That's better. Okay. The cursor duplication, is that intentional? I am not seeing cursor duplication, so I don't know. Let's see. Import star means to import everything. Yes, if you do like from math import star, then it imports everything and removes the need for you to use the like math dot or TKinter dot notation. The problem is that's dangerous if you have things that can be overwritten by the module. So I generally recommend against it. But for TKinter, that seems to be the way most things are done. All right, so now let's take a look at this window. This is a little bit better. You can see that it has a bar. It has a title up there. If we click, you can see some stuff that we have no code in our program that puts this up there, but we can resize it, we can close it. We have a minimize button, we have a maximize button, right, that kind of do this for us. There's nothing else in here, but those basic functionalities are there. And of course, we have the little red X button that we can click on to make it go. And you'll notice that when we click the little red X button, what we end up getting is we end up getting hello finally being printed out. So let's run that again, right? We go through, we bring up we create the window, we put it into we print out getting started, and then we put it into our listen loop, and getting started is here, but our hello is not anywhere to be seen. So our program is running. We're now sitting in our infinite loop. Line 13 is not getting executed. And then when we click the end button to kill our infinite loop, only then do we proceed on to the rest of the program and print our hello. Okay, so our program is in a main loop. It is listening for events because things like clicking on these buttons are actually events. that occur, right? We click on this event, that event kills the window, and we print out our hello. Okay, and this is not the only way to do this. We can just do import TKinter, I believe, or is it TK? No, it has to be TKinter, right? If we do this, this is the way I would most normally run my programs, and then you would do something like TKinter.tk to actually get the access to the module, and this will run as well, and this is actually safer and a better way to do it, but it does require you to type in more actual characters. When you're referencing functions from the TK package, from the TK module, you would have to preface them with the TKinter module. Okay, so does that make sense? All right, so this is the first little program. Let's see. Yeah, that looks good. It's pretty boring. We can't actually do anything, so now let's do some stuff. There's two main types of things that we have in our program, and they are containers and widgets. And containers and widgets. Can you guys see that? Yeah. So widgets are things that are there. You can see them. You can interact with them, right? So they're buttons, they're drop boxes, they're text boxes. The main ones we're going to deal with are buttons and canvases for this class, but there are a lot of other ones that you can select from, and TK has a very good, let's see, somewhere in here we have a link to the documentation for TKinter, so you can actually see those. Okay, so these are widgets. They're things you interact with, things that you see. They are the main part of your program. But GUIs also need a way to organize stuff. And you organize stuff by using containers, right? So containers can hold containers and widgets. And you can put your widgets and your containers into widgets and containers into other containers so that you can actually organize the way they fit together and how your interface actually looks. And the cool thing about it from a graphics, a GUI point of view, is that most of these packages that allow you to build interfaces using containers allow you to resize things and actually make some kind of intelligent choice as your windows get bigger or smaller. So if we put it in a place to draw, and then we put a canvas widget to draw on, and then we resize our window, we don't necessarily want our little buttons getting bigger and bigger. What we want is the canvas area getting bigger and bigger, so we have a bigger thing to draw in. We'll see this a little bit, but the idea is that we can specify some of these things, and then these containers can grow and shrink to fit the stuff within them, and they allow us to organize, and they allow us to be somewhat flexible to the size of the window we're actually displaying in. All right, so let's take a quick look at one of those. This is going to be a slightly bigger example. You'll notice I'm doing a lot of cutting and pasting today. We're going to go through a lot of code, and a lot of this is repetitive and boring, so I am not going to try typing it, but we will walk through it after we're actually have it in the window. Okay, so let's look here, and we have our same from TKinter import star, right? So this is the same import statement we had before. We're still creating our root, and then down here we are actually running our infinite loop. So let's look at the stuff in between, right? What we're actually going to do is we're going to start creating some frames, and frames are containers, right? So let's look at all the frames we create. Right, there's one, the main frame, and I'm going to tell you that the main frame is going to be the main thing, the overall container that is where we're going to put everything. And you'll notice that when we do the frame call, what we provide it with is this root name, right? So root is actually the parent of main frame, and then we'll create a top frame, and we'll create a bottom frame, and we'll put both of those in our main frame, right? So now we have kind of a hierarchical order. I'll draw this out in just a second. And we'll take some buttons and we'll put button 1 in our top frame. We'll create another button 2 in our top frame. So our top frame, we have a main frame that has is a container, contains 2 other containers, top and bottom. And now we've put in 2 buttons. Buttons are widgets, left and right. Okay? And then we'll do it again in the bottom frame, bottom 1 and bottom 2, top 1 and top 2, not left and right. Okay, and now we got to look at all these pack things. Well, what the pack does is you can put something into a frame, something into a container, right? So we create a container that's the child of root, but it doesn't actually put it into the root, doesn't actually put it into the GUI until you do a pack. So we take our main frame, we declare it to be a child of root, and then we pack it to put it in the frame. And then we take a top frame and we pack it, top frame in main frame, and we pack it. And this time we're going to tell it that we want it to be on the top side. And bottom frame will do the same thing, except we'll tell it we want it to be at the bottom side. And then we put in our buttons, right? We put in 4 buttons, 2 in the top and 2 in the bottom, and pack them left and right. All right, so let's, I think, quickly go over to our handy dandy notebook. Right, so what does this look like? So we have our root window, and root is the main window. It has all that stuff. It manages all the buttons on the outside, the destroy button, etc. Right, so this is root. Then within root, we have an invisible box main, and we can put things on the box like on the container. This is our container. This is main frame. Right, so this is our container. We can do things like add edges and visual effects to this container to show where it is. But in general, it's just a thing to hold stuff. And then in there, we have 2 other boxes. Top frame and bottom frame. And then in each one of these we have buttons. I should put the buttons in a different color because they're actually widgets. All of these blue things are essentially containers, right? And then we have our green buttons. Okay, it's going to look something like that, I hope. And another thing to notice is that our frames, as well as you can see them, are only going to be as big enough to actually hold the stuff we put in it. So everything's packed so that everything fits nicely. We can expand it if we want. We can expand the main root if we want, but everything else remains, pretty much just packed into this little area. And you can see that we have buttons. You can press them. You get, right, part of the widget code is when you click on it, it does something. It basically looks like it's being pushed in. But we haven't actually attached any code to it. So other than the visual effects that comes with the widget key, nothing else really happens, right? But this, at least we now know how to actually put buttons on our screen. All right, let's kill that. I'll run it again just because I think you guys didn't actually see me hit the run button. I could have magically made something else appear, and there it is, and we can kill it again, just because there's not really anything left to do. Okay, so this is a very simple program, and again, it still doesn't do anything, but it does it very stylishly. It allows us to do nothing 4 times with 4 different buttons. And here's just a little representation of the nesting. You'll notice that this is very hierarchical, as we showed in our diagram on the whiteboard, right? Everything starts out with this root GUI element, and then main frame has as its parent root, and then we put top frame and bottom frame into main frame, right? So main frame is top frame and bottom frame's parent, and root is actually their grandparent, and then we can put buttons into top frame and buttons into bottom frame, and everything kind of nests down in this nice little hierarchical structure. And it turns out that whenever you create a frame, button, canvas, etc., this nesting is really important. You need to know where things are supposed to go. So this okay, the story of your life, pointless buttons. Yes. Whenever we look at our code, what we can see is that the first argument is always the parent, and other arguments can be added. Like for here, for the button, the first argument is the parent, and then we tell it what we want it to say, top 1 in this instance. All right. And finally, the other thing is we needed to pack these things in order to make them work, and parents resize depending upon the size of their children. Okay, anything else here? Not really. All right, so let's look at this code for a second by clicking in the right window. All right, so let's look at this code. We're doing nothing. That's a stylish nothing, like I said, but we're doing nothing. And already we're at 29 lines of code, essentially. And we could get rid of some space and everything and make this maybe 24 or 25 lines of code. But this is a lot of code not to do anything. So things are starting to get complicated. And when things start to get complicated, as computer scientists, we start thinking about how are we going to simplify this. And I'm going to tell you there's another complication. If you want to, for example, count something, like count how many times a button is pressed, maybe go up on button 1 and down on button 2, well, then you need to share a variable, right? And sharing variables, we try to avoid using globals. I know everybody thinks globals are an answer to everything, but globals are really not all that great of a thing to use. They result in a lot of errors in code, especially as your programs get more and more complex. People overwriting global variables with other global variables, etc. So we try to avoid globals whenever possible. We use them sparingly, if at all, and we don't need to use them here. But we do need a way to communicate, among the different buttons and among the different actions we want to do if we actually want to coordinate things. And you'll see in a few minutes that we do actually want to coordinate things, right? So we have our code. It's getting increasingly complicated, and we have no way to easily share data among all the buttons and among all the actions we want to go. So just like as our programs got complicated, we started breaking them up into functions and then eventually breaking them up into modules and classes. We're going to use the same approach here. And in fact, what we're going to do is we're going to start using classes to actually run our TKinter programs. Okay, so that was kind of a long drive-in for, something that's really kind of not all that earth-shattering. So let's grab this. Here's the code. And I'm going to tell you right away that this does exactly what the other code does, except it does it using classes. Okay, so we're still doing our import, and now we have this class myApp, and let's ignore that just for a minute. Come down, we have our little guard here, if name equals main. So if we're actually executing this file, we create a TK window, and then we create an instance of my app, right? So we're going to create the root window. We'll create an instance of my app, and we'll pass in the root, just like we would as if this were a widget or a frame container. And then once we're done, we'll start our root. Once we've created our app, we will start our infinite loop on main loop. Okay, so let's look at what we have in my app so far. Well, class my app is actually pretty simple, right? So far, we've only created our initialization routine. And remember that this gets called when you create an instance of the class, right? So my app is the name. We're creating one here, and we're passing in this root variable. Well, our initialization function needs the self pointer, the self reference, I guess is the right way to say it. And then we have this other parameter parent that corresponds to root. And what it's going to do then is it's going to build exactly everything we did before, right? We're still creating the mainframe, and we're giving it parent as our, instead of building it down here, we're creating it within the initialization function, and we're creating it to have root as its parent, right? And then all the rest of this code is exactly the same, except that everything has self dot in front of it because this is now a member of the class, and these are all main frame, top frame, bottom frame, button 1, button 2, button 3, button 4 are all attributes of the actual class. Okay? And quite honestly, at some point we will probably do this, but I'm going to put in right now, we probably also want to save off the parent so that we have reference to it later. It's going to be important when we want to actually kill our program. And I think we get to it in probably about 10 seconds, but I'm just going to put it in now. All right, so if we run this, what we're going to find out is that this doesn't actually change anything, but arguably it's better organized, because now instead of having this be an ever-growing list of things, we've kind of encapsulated it all in our class, and we can create the actual interface in our initialization function. Okay, and that just kills, just the way it's supposed to. All right. Okay, so now this is what we're going to want you to do when you're actually writing a visual program, a program with a GUI. Is you create this class and you pack all of the initialization code, all of the building the GUI into the initialization function, and then we can start looking at ways to put on more actions and make it do something as opposed to nothing. So the thing we're going to use most here is we're going to use button clicks. And I think, in fact, the only action we're going to use is going to be button clicks. We will draw into a canvas, but we're going to only use button clicks in what we do today to do activities, I think. Yeah, I think so. So let's get started on this. When we looked at button, we had stuff down to here, right? And you remember that we put top 1, top 2, bottom 2 on our button, and that was this text label, right? So this was the parent. This was the text label. And it turns out that there are other commands we can provide it to as well. In fact, one of the commands we can provide it with is a command to, well, whatever we want to put in there. This is a member function of our program. Let's take a look right here, right? This is a little bit simpler of an example. Let's pop this in here, and then we'll talk about this one. Okay, and all right. Remember I told you we needed self.parent? There's where that goes in. You'll notice that this is a little bit simpler for the initialization function. We're not putting 4 buttons up there. We're only putting 1 button up there. We're going to give it the text quit. And we're going to give that command, we're going to give that button something to do when it gets pressed. So this command says do this when you're pushed. This has to be defined somewhere. Because we have the self there, we know it has to be within the class, and there it is, right? And all this is going to do is it's going to do, well, it's going to do patricide or matricide, parenticide. It's going to look at the overall parent of the GUI, right? In this case, we're passing it in with root, right? It's going to look at the parent, and it's going to call the destroy function on root, which is a function, you know, that's defined on our root. Okay, so again, this is kind of simple. You'll see that we do a little bit of configuring to make the button prettier. You can change these if you want. Let's run this. This should have one quit button. The pretty part there. This extra space around the quit is because of this nice little 4M kind of thing. And now when we hit the quit button, what we actually do is, well, does exactly the same thing. Come on, baby. There it goes. Does exactly the same thing that the X button would do, but it allows us to put a quit in our program instead of forcing us to always hit the X in the corner. All right. So there's our first example of something that can happen. Dang it again. I hate when I do that. Test results will come out as soon as we have them. Unfortunately, our TAs were not able to finish yet. I'm a little bit annoyed at that, but we are working on it. Okay, we can change this. We can make this, I don't know, 12M, and run it again. And what we should see is we should get extra space. Yeah, see, that's now in the X and Y. It's bigger. We can make this 48M. Right, so this just controls some of the padding, some of the space around our button. We can reconfigure it, make it however we want it to look. All right. So now we have a button that does something. Right, we've configured our button so that when we press the button, we kill ourselves by killing the root of our program. Okay. Boy, this is lagging pretty badly. That's why I don't tape most of the time. This coming back or not? There we go. Okay, good. All right, so we've looked at some pretty basic things. We've looked at attaching text. We've looked at sizing things. We gave a width to our button, and then we did some padding on it. We looked at packing things. We created some buttons. We made the buttons do something. So let's look at one more element, and that element is going to be our canvas widget. So canvas is basically a big blank area. And you can draw things in it, put text in it. It's a way for you to communicate with the user, for you to provide output to the user, other than just the animation of a button being pressed, etc. So it's pretty simple. You create a canvas the same way you create anything else, right? You call the canvas the TKinter canvas call to create a parent. To create a canvas, you give it the parent. You give it some optional parameters like a height and a width. And then you pack it into your GUI. And then once you have that, there are calls within Canvas to do things like, for example, create an oval. So this creates an oval. Where does this create an oval? Let's see. Since this is a module, we should be able to ask for help on it. Okay, so x1, y1, x1, x2, y2, right? So the arguments to the oval are x1, y1, x2, y2. So this should create an oval at 40, 80. Here we go. Well, just in case the help isn't good enough, we can always go to the TKinter, to the Python TKinter documents. They've got really good syntax, or very good documentation. And you can look here and get all sorts of sample code and run sample code and create, what did I want to do? Create yeah, it looks like it takes a tuple with x1 and y1 and x2 and y2. All right. At least if it's consistent. All right, I'm not going to... Actually, I think that it would have a center, and then that would be the x and y extents. All right. I'm not going to fight with this anymore. All right. We'll play with this in just a second. Is this going to be on the test? Yes, absolutely. But it doesn't, you don't, so the stuff we're covering is going to be available for the test. You should think about, if you look, there are some lecture exercises. That's the level of what you should be thinking about. We're not going to ask you to write a huge program. We may ask you to put up some buttons. We may ask you to do a few things, write a small program. We might ask you to go over and be able to trace through the program like you're doing in the lecture exercises we give you to say what would actually be the output or what would happen. So yeah, this is not, we're not looking for you to be experts. But we are looking for you to kind of be able to, right, this is just creating a module, right? This is just creating a class. So being able to do something like this, you should be able to, you should be able to understand, okay? You have to know how it works. You should be able to do something simple, right? We're not going to ask you to, this I could ask you to do. I'm not going to ask you to do something like the last thing we're going to do in the class today, but yeah, you should be able to do this stuff. Anything in the lecture is fair game. All right, does that make sense? All right, you should be able to create a button. You should be able to attach a command to it. You should be able to create a canvas. You should be able to draw on it. I'm trying to figure out what the X1 and Y1 is on the circle. So we'll play with that a little bit. Okay, where are we now? All right, so now that we've talked about Canvas a little bit, let's go back and I'm back to here, I think. Okay. So, I should have just read here. So for the canvas, I forgot what this was. You create a box from 40/40 to 80/80, right? And then you put a oval inside it that is tangent to it at the center of the top and top, bottom, and sides. So that's how you create the elongated shape. This creates a box with one corner is 40/40, one corner is 80/80, and then draws an oval within it. With a canvas, you remember that we had when we're talking about I/O, when we're talking about a print function, we had this thing to flush the buffer. Flush equals true. Canvases are the same. They buffer output. So if you want to actually make them come out at a specific time, you can do a canvas update to force the update, to force everything to happen at once. And there's also, in case things are going too fast, you can specify a wait time that allows you to make things happen slowly so that you can follow them with the eye as they visually develop. Okay? And these are pretty standard decorators that can be applied to other GUI elements. And they just, like I said, they don't necessarily affect how the program runs, but they do affect how the program actually appears to look. All right, so let's take a final look at this. This is our final program. This you should be able to understand. This would be too long to give on a test, but you should be able to understand the elements and be able to deal with them. So let's get rid of, and you should be able to do some of these simpler types of activities. We're not going to ask you, to do anything too complicated, but creating a button, populating a button into a frame, and setting up a command to kill your window are reasonable. So just make sure that we kind of follow that logic and kind of make sense. Yes, there is no exam 4. There is only a final. The final will be on December 15th, I believe. It is cumulative. This last material will certainly be a significant part of it, but it is cumulative, okay? Test results will be out as soon as, and again, test results will be out as soon as we have them. I'm hoping by the end of, hoping before next class. They were due today. They were due yesterday. They are not done yet. All right, so let's take a quick look at this. Actually, you know what? Let's run this first so you can see what it does, and then we'll take a quick look at it. So this is what it does. You can see here we're putting a little bit of text up in the top. This whole thing is our canvas. Oops, made it go away. This whole thing here is our canvas. Here are our buttons down below. When we press the draw button, we draw some circles. How many circles we draw is gated by what this number is. Clear just gets rid of it. Increase increases the number of circles we're going to draw. Right now we draw 32. Reduce reduces the number of circles we're going to draw. Now we're drawing 8. And then, of course, quit allows us to quit. So let's just see how this is all, how this all hangs together. All right, I'm going to try. I don't know if I'll have time today, but I will try to get this one uploaded. That's why I'm doing the taping on it. I wasn't completely happy with what I had before. I did give you a little bit of a precursor, the first part of the recursion function as well. We'll talk about that starting on Thursday. Okay, so we have our class. And our class has the initializer function, pretty standard. One thing that is different in this one is we did a local function. So this new button function is only available within our init function. And what this is going to do is it's going to set up our buttons so they all have the same look, right? So you see that we come in, we give a parent, we give a command, what we want to execute when the button is executed, we give what we want to be displayed on the button, and we give it a pack location. Okay? We come in, this new button command, when called, creates a button using the parent, right? It nests it under the parent, under the container class, and it sets the command, what gets executed, to whatever is passed in this command place. And then we use the button configure to set what the button says. We have a button width, which is specified down here, and some pad values specified here and here, right? So all of our buttons look the same. And then we pack it into whatever side we asked it to be packed. So this is just a little utility that takes the place of about 4 lines of code that allows us to more quickly set up our buttons and make sure that everything has a consistent look and feel. Okay, so we've defined that. We've defined some local constants. If we want to change our button width or we want to change any of this stuff, we can change them here, and it changes it for the rest of the program. We also set up some local attributes for repetitions. Repetitions will be how many circles we're going to draw, wait time, how long we wait between drawing one circle and the next, and the size of our canvas. And again, these become attributes that are maintained, right? Notice they have the self dot notation, so they are attributes of our application class that comes in under my app. We're saving away the parent, and now we actually start the work. We create a main frame, we pack a main frame. We set the draw frame. This is going to be where we actually put our canvas, and we're going to pack that onto the top. We create our canvas in the draw frame, and we give it our canvas dimension width from up above, right, from this. I'm sorry, this is our info canvas. This is where if you remember that little place where we, up here where we put our information, this pound number of circles equal 2, right? That's what we're setting up. So we give this a height of only 20 because we don't need a lot of room for that, but we want it to span the entire dimension of our canvas, right? So we mark that there. We're going to pack that into the top of our draw frame. And we're going to actually give it some value, and the value is going to be, right, we just set in it the string that says how many circles we currently have, which is in our self.repetitions variable attribute. Okay? So this sets our text area, right? This is sets up the text area on that little canvas, that info canvas we set up, and puts into that text area this little string, right, which we've seen. Get that back. Okay, so now we have all of that little decoration up there. We'll put up our main canvas. So we will set, this is just going to be a bigger one. It's going to be 600 by 600 in this case. And we will pack that on. So now we have all of the canvas, all of the drawing area, and all the informational area up there. So we will now set up, we create a button frame, a place to put our buttons, and pack that underneath the canvas. And now we set up, we use our new button command to set up 1, 2, 3, 4, 5 buttons. One for draw, one for clear, increase, reduce, and quit. Right? And for them, we give them methods from our class: self.draw, self.clear, self.increase, self.reduce, and self.quit. Okay, so that sets up our entire system. It sets up the entire look and feel of it. You'll see that that's all in the initialization class, and that's typically what you do in the initialization class is you define some initial values for your attributes, and you build your interface. And now let's look at what's left. Well, self.clear, I guess we'll do draw last. We'll do the rest of them in order. Right, self.clear, all that does is it takes our main canvas, right, which is right here, and clears it. It gets rid of everything. Okay? So that just basically gives us a blank slate. Reduce is going to reduce. Now these are not in order, but that's okay. We start out at 2 repetitions, and reduces it by a factor of 2 until we get down to 1. It won't go below 1. So it'll always draw at least 1 circle. And that's all this does. It checks to see whether our attribute variable is too small already. If it's too small already, it does nothing. Otherwise, it decreases it by a factor of 2. And then, it's calling this little put info method. Well, let's look at an increase. Increase doesn't allow us to go up to infinity. It allows us to go, well, it allows us to go to 256 essentially, but it doesn't allow us to go beyond 400. However, we start off our initial one, we can get up to 398, I guess, depending on how we set it initially. But since we start at 2 and we're using perfect 2s, this will allow us to go up to 256, but not beyond. And then it calls the put info. Okay. Let's go down and look at quit. Quit is just like what we saw before. It just takes the my parent, the attribute, the parent attribute, right, the root window, and does a destroy on it. Okay, so now all we have left is to look at the put info and at the draw. Put info, nice comment so that we know what it does. It changes the text field in the canvas. So it's looking at that information canvas where we have the pound number of circles, or the number of circles, and it's reconfiguring that item to reflect that we've changed the number of repetitions, right? So as we decrease or increase the number of repetitions, the number of circles we're drawing, we're going to use put info to put that up in the little information canvas at the top. Okay, so now let's look at draw. Well, boundary offset, quite honestly, that's just a local variable that allows us to stay within the canvas. We set a max radius based on the size of the canvas. Essentially half the size of the canvas minus some of that boundary offset. We start off at a smaller radius, right? Each one of our circles is going to have a growing radius. So we set up an initial radius. And I think XC is... XC is where we're going to, when we draw our oval, right, we have to put a bounding box in there. So this is essentially the box for the entire center of the for the entire canvas, so that we can create an oval based on knowing where sorry, that's a center point. So we can find our center, and then we can create our box for containing our circles. Doing modifications from the radius on that center. Okay, and then as we go through, sorry about that. As we go through, we just, every time through, we add on a little bit to the size of our radius, we draw our oval, we add a little bit onto our radius, we update the canvas to refresh the drawing, and then we wait so that the eye can catch up. And that's really all there is to it. Let's run this again and let's play with it a little bit for a few minutes. Right, here's we have two circles. We can draw two circles. They look like that. We can clear it. Let's do a lot of circles. We'll go up to, right, 128. We can increase to 256. Now we're greater than 200. We can't create any more. We can do a draw. And you can see we get a little bit of aliasing effects in there because we're drawing things that increment isn't quite, you know, there is some inaccuracies because of mathematical computations in discrete arithmetic. We can clear that. We can reduce it a couple of times. We can draw again. We'll draw fewer circles. We have the quit. We can draw that. All right, so everything's looking pretty much the way we want it to. As we draw the number of circles, as we increase the number of circles, we are seeing the number go up. As we decrease, it goes down. One thing I want to show you is that I told you before that things run in parallel. So right now we're drawing circles. If we hit clear, we'll clear the canvas. We haven't killed the draw part. It will still continue to draw. But, right, we clear, we get rid of the inner, clear, get rid of the inner, clear, get rid of the inner. All the time the draw is still going on until it reaches the outer limits. We can even do something like this. Let's reduce the number of circles down to 32, do a clear, do a draw, and now, right, we were drawing 256 circles. We hit the clear. We got a clear center. We decreased the number of circles. We hit the draw again. We drew the decreased number, and then the larger number came back on again. So so Python is used in statistical analysis. It's also used in machine learning. I don't know what stats module I would use, but there's doubtless numbers of them. You can also use things like TensorFlow for machine learning. You can use NumPy for general numerical calculations. There's a program called Eigen, I think is C. So yeah, there's lots of packages used. That's one of the reasons we actually teach in Python for CS1 is we have a lot of engineers in here, and one of the things that is going to be very useful is that Python is so extensible. Python's open source, by the way, which means that you're free to use it. You can get it for free. You can also pay for it. There's nothing that says you can't pay somebody else to provide you with it, but you can get it for free. You can download it. All the modules have to be licensed with some open source thing, so you can share source, and you don't have to worry about using something and having somebody jerk the rug out from under you because they don't want you using it. Data structures will use C and C++. So that's going to be the hard part of the class. We'll talk about that a little bit next a week from Thursday. There are some practice things going on where you guys can get a head start on learning C. So yeah, let's see, what else did I want to tell you? Anything else on this? I think that's probably about all we wanted to go into today. When we get to recursion, we're going to use this same thing to do. Let's do a couple other things here. We're going to use this same kind of structure to do some other. We'll use this to draw the Sierpinski triangle and maybe a few other things that are kind of interesting and fun using recursion. So you'll get some practice using this. You'll use this today, and I think you'll actually use this. You'll do some lecture exercises today, tracing through the programs, and then you'll do some some lecture exercises on Thursday using recursive versions of this program, modifying some things there. Let's set the wait time to be a little longer. Let's make this 40 so that we can see it going a little bit better. And what else do we want to do? Let's make our canvas, when we create our canvas, let's make our canvas height width. Well, let's do this. Let's do let's try this. Let's see what happens here. Okay, if I'm right, this should create a should create one, it should draw more slowly, and two, it should create a oval instead of a circle. Okay, so let's just draw with this. Yeah, okay. We'll clear this, we'll increase it, 256. Right, so now, because what we've done is we've modified the radius in the x direction. Come on. Keep up with me. There we go. Right, so you can see it growing more slowly, but at the same time, by modifying this line, we've now created an oval. We've created a vertical rectangle where it's half as wide in the x direction as it is in the y direction. So by playing with these things, we can make a whole bunch of different modifications to make things look different or better. We can change our wait time, right, to 40, so that drew a lot more slowly. Let's do it 200. That'll draw even more slowly. Means we probably ought to quit this. And we will run again. And I think that this is probably, right? It's looking really nice on my end. Unfortunately, you guys aren't quite getting the benefit of all right, I'm going to let this come up and show. See if this does faster this time. Nope. We're getting bogged down. All right, so I think we're going to I'm going to cut this here. So this is just a quick little introduction. You should be able to do most of this stuff. You know, you do need to know this a little bit. We're not going to ask you to do something incredibly hard, but you should be able to, you know, look at the exercises from today and for Thursday and make sure that you can do those. And if you do, you should be in fairly good shape. With that, I'm going to stop lecture. I'm going to also stop the recording.